Hi, Deirdre Macnamara here from Letterkenny IT. In this video, we're going to take a look at simple and compound interest. Okay, at the end of this video, you should be able to understand what simple interest is, take a look at what compound interest is, and be able to calculate both simple and compound interest, and also then to take a look at the present value of money and calculate that. Okay. So in this scenario, often you're faced with investment opportunities and you can have the money up front, or you can wait a little while and get a different value at the end. So for example, if you were faced with the choice of €1,000 now or €1,000 in the future, well, most people are going to choose now. They'll choose now. If you're given a choice of €1,000 now or €2,000 in the future, well, if it's tomorrow and you get the €2,000, you'll probably go for this. But if it's 30 years time, you'll get €2,000. Well, then you might choose. So it's not very obvious which you'd go for. Okay, so it depends how far in the future. And if you're given €1,000 now or €1,100 in 1 year's time, it's only a small jump there. Actually, the length of time it takes to make that small jump will determine when you want it. So it depends on how big the jump is, and it also depends on how far in the future that will be. So the thing we learn from this is money in the future may not be worth as much as money now, and it depends on how far in the future and how much the money rises. Okay, so looking at discounting then. Discounting is where you're discounting the value of money in the future in comparison with money now. So in other words, a bird in the hand is worth more than two in the bush. Okay, so simple interest, when interest is calculated on the principal only, i.e. the amount of money you invested at the beginning. Okay, so if you invest money over a 5-year period, you're only getting money or interest on the money you invested in the beginning. You're not getting interest on the interest itself. So compound interest is where the interest itself is reinvested and you don't take it out, and the interest also earns interest, and we'll take a look at that. Okay, so you decide to invest €8,500 in an investment account paying an interest rate of 5,000 or 5% per annum. Okay, PA is per annum. What interest would you receive at the end of each year? Okay, the answer is 5% of 8,500. So we've done this one before. So 5%, another way of typing that in your calculator is 0.05 as a decimal. That's what 5% is. So multiply that by 8,500 and you'll get 425. Okay, so that was easy enough to do. Now here is the formula that we use, and you're thinking it was easy to do it, and now we've brought in this formula which sometimes makes it look a little bit more difficult to do this maths. Okay, so the interest is going to be, okay, that's a simple interest amount. A0, 0 means at the very beginning of time, the amount you put into the bank account at the very, very beginning, multiplied by the rate as a decimal, multiplied by the length of time. T is the time, or the number of years that you invested the principal amount. Okay. So what is the simple interest gained from an investment of 120 for a year at an investment rate of 8%? Okay, so we're going to use the formula. Okay, so we had interest equals the amount invested at the beginning multiplied by the rate as a decimal multiplied by the number of years it was invested. So the interest is going to be 120, which is the amount you invested, multiplied by the 8 over 100, or as a decimal, multiplied by the number of years. It was 1 year. So that's us filling in all the bits and pieces, and then you calculate it out, and you get 120 multiplied by 8 as a decimal, which is 0.08 multiplied by 1, which works out at 960. 9.6. Okay, so a sum of 120 is invested at simple interest for 5 years with an interest rate of 14% per annum. Okay, what's the interest that is paid over the 5 years, and what is the value of the investment? Okay, so that's going to be the 120 multiplied by 14 over 100 or 0.14 multiplied by the time, which is 5. You've got 5 years. That's why the 5 is here. So 120 multiplied by 0.14 multiplied by 5 on your calculator will give you 84. So this is the interest you've earned. The value of the investment is going to be the 120 plus the 84 and gives you 204 euros. Okay, if the interest gained each year is added to the principal value, we're looking at compound interest. Okay, so instead of taking out the interest every year, the interest is actually gaining interest itself. 1 second now. If the interest gained each year is added onto the principal, the principal saved or the amount of money you invested at the beginning, we're looking at compound interest. So compound interest is where the interest gains interest. Okay, and the principal carried forward, or the amount you have invested carried forward, gets larger and larger, and the interest is compounded. So take an initial principal of €1 with an interest rate of 10% per annum. After 1 year, the €1 is now worth 110. Okay, so 10% of €1 is 10 cents, so you add it on. So at the beginning of the second year, you now have not €1 invested, but 110 invested. Okay, so the interest for the second year is going to be 10% of 110, which is 11 cents, and you add that 11 cents on to the 110, and you get 121. And the same will happen in year 3. Okay, so that's what compound interest, where the interest gains interest. Okay, you decide to invest 8,500 at an investment account paying an interest rate of 5% per annum. This time all of the interest is reinvested and the interest will gain interest. How would the 8,500 have grown to at the end of the 10th year? Okay, so going back to our original formula, the principal at the end of the first year is the original principal plus the interest earned. So that's 8,500 plus the 8 divided by, or the 5 divided by 100, which is the interest rate as a decimal, multiplied by the 8,500, which is your interest. Okay, so that's the original amount plus the interest gained, which is 425. So at the end of the first year, going into the second year, you will have 8,925. Okay, for the second year then, you start off the second year with 8,925 and it gains interest. So here's the interest it gains and here's the initial investment. And so going into the third year, this is what you're starting off. And you could do the third year, the fourth year, the fifth, and the whole way through to 10 years. But this would take a very, very long time. Okay, but it just was too cumbersome. It takes too long to do it that way. So some whiz of a mathematician has created a formula, and there's a formula that's used now to calculate compound interest, and it's been checked and we know that the formula works. So we can just rely on the formula and put in the numbers and out will come the correct answer for you. So this is the formula that's used for compound interest. One of the things is that often when people see formulas like this, they panic and they go, oh, I can't do this. This is just a formula. We've done it in the past. We just have to slot in the bits and pieces and begin to understand the language of maths and what these different symbols represent. Okay, so we've seen A0 before. Okay, so A0 is the amount of money you invest at the beginning. Okay, 1, that's easy enough to understand, plus or over 100, we've seen that. That's your rate of interest expressed as a decimal. So that's the 5 over 100 if it's a 5%. And T we've seen before, and this is time, and this is an indice. It's to the power of the length of time that you invest the money. Okay, so let's not panic and just work this one through. Okay, using the formula with the example we have, we get the following. A0, and again, write out what each of these different bits and pieces are. So A0 is the amount of money you're investing at the beginning. That's the 8,500. T is the 10, okay, 10 years. R is the rate of interest, so that's 5%. Okay, so filling it in over here, okay, so AT, okay, that's the amount of money you're going to have at the end. That's the 8,500, which is this thing here, A0, okay, multiplied by 1 plus the 5 over 100 to the power of 10. Okay, again, BEDMAS says you have to do what's in the brackets first. Okay, so 5 divided by 100, division. So 5 divided by 100 is 0.05 plus 1 gives you 1.05. Okay, BEDMAS now tells you that you have to do exponentiation next, okay, to the power of, or to the indice. Okay, so now we're going to do this bit next on our calculator. Okay, so do this on your calculator. So 1.05 to the power of 10 gives you this. Oh, sorry, I didn't mean to go back forward. And then once you've calculated this, keep the full details on your calculator, multiply it by 8,500, and you get